at another problem. The same thing, looking at a function, and this is our cell phone bill. And this one's a little different because it says t equals 0 corresponds to 2000. And you might also see it as t is years since 2000. You might also see that. They mean the exact same thing, and what they're telling you on your chart is that if you put 0 for the t, then that implies you are talking about the year 2000. And if you put 5 for the t, or 10, 15, 20, and so forth, that you're adding that on to the year 2000. So 2000 plus this 5, that would be talking about the year 2005. 2000 plus the 10 would give me the 2010 for the year. This one would be 2015 and 2020. Okay, and then the same thing as always, we're plugging in the 0 into the function for t, and this is the years since 2000, and this is the cost. Okay, so let's look back at this function a little bit more. The independent and dependent variables, remember it always goes dependent by independent. And so here we have c of t, so that means our independent is going to be the t, which is years since 2000, and our dependent is going to be our c, which is average annual cost, and that's the description for it. And then the units are in dollars per unit. And yes, it's a long one, but if I leave off half of that, it doesn't make as much sense. So then the relationship between the quantities, we're going to say dependent by independent. And then dependent, remember that's the cost, so average annual. And what are we talking about the cost of? This was cellular service. And then by year. Because the independent variable is the year since 2000, we don't have to put the units in the title. They do have to go on the sides of the graph though. So then for a domain, we're thinking, what is the smallest value that we could have for the independent variable? And so we're looking at the t. That's our independent variable, the year. And so when we're looking at the year, we know the smallest value is 0 because our function is defined for the number of years since 2000, or t equals 0 corresponds to 2000. That means starting at 2000, we've defined this function for cell phone cost, but we have no information for before that. So we always start at 0. It can't be any smaller for this type of function, and it could increase. We don't know how far. Eventually, the function's not going to be valid anymore for the cell phone cost, and we would need a new one, but we don't know when that's going to happen. So we'll just say 0 for the smallest value for time to infinity with a parenthesis. Remember, the infinities always get parentheses, and in this case, the square bracket means that you could have a time 0, and when we look back here, t equals 0 is defined as the year 2000, and that's the first year that we can use. So that's why we put the 0 here, and the 2000, the first year we can use, and then we figure out what our c of t's are. If we want to put things onto our graph, the title, remember we will always want to write the title here. This would be the average annual cell service cost by year. And then if we're going to label these, remember it's dependent off to the left. And independent across the bottom. So it's dependent by independent in that order, dependent and then independent. And the independent variable was the years. So this is my title for my graph, years since 2000. And the dependent was the average annual cost in dollars per unit. I'm trying to leave some space there to put my scale. So when I take this function, let's see if I can write it, 66.7t plus 131. There's my C of t function, and I plug in these values for it. Then, oops. Then I can start seeing what my graph is going to look like. So I have 66.7 times my first t, which is 0, and I get 0. That doesn't surprise me. And add 131. Again, no surprise, I should have a 131 there. And then my next one, 66.7 times 5, because I wanted to do 5 next. And then I will add $131. And so I have 464.5. And so that means the average annual cost per unit for a cell phone in 2005 was $464. And I want to jump up and do the last one just so I have 3 points there. So I'm looking at 66.7 times. Now you notice I'm plugging in the t's, not the years, because if I plug in the years, I'm going to get giant numbers that really don't make any sense for my function, because my function, it says t equals 0 is the year 2000. So for every year after, it should be the number of years after 2000. So 20 times 66.7, and then I'll add in the $131, and I get $14.65 for the 2020. And so now I can see I need to go from 131 to 14.65. And to do that, I need to go up to about $1,500. I need to put in my domain, the independent variable over here, and that goes, those are these here, my t's, that's what's going to go there. And I have 0 to 20, so maybe just start 0, of course. Always start 0 right at the edge there. Don't skip any. So whatever scale you have has to work for the whole way across the x-axis. We never skip on the x-axis. So 0, and then maybe that's 5, 10, okay. And then on the y-axis, I need to go from 131 to 1400. So I'm thinking I might want to jump up by here. I think 14, I could probably do 14. How many do I have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I could, that would get me to 12. So I'm going to have to go, okay. So I have 24 blocks here. And so if I divide that in half, then I could go as high as 12 if I'm going 100 per block. So I'm going to need to scale it down just a little bit. So I think I will put this as 200. Then I'll make this 4, 6, 8, 1,000, 1,200, 1,400. So every block is 100 on that scale. Then 0, 131. So 0 in the x direction, there's 100 right there. So about a third of the way to 200. And then 5, I'm at 464. So a little past halfway towards a 5. And then at 20, I'm at 1465, which is getting closer to the 1500 mark. And then try to draw a straight line there. And now I can make estimates off of that line. So there's one worked all the way.